Well, welcome to the December 2nd, 2025 session of TAPR and HamSCI technical session. My name is Dave, KV0S, and this week I've been trying to set up more of the multicast part of not just my Whisper Demon, but um, some I have some other B links that I've been playing with the multicast, making some progress, also finding where I get stuck in places. And I've also been looking at some of the stuff that Michael Howen's been doing. Quite interesting. So, next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. I've been quite busy also. I think the thing that is on my mind right now that I've been working on is looking at some of the ground magnetometer data from the PSWS magnetometer I have installed at my house. I looked at data from the Gannon geomagnetic storm, which happened in May of 2024. I have really nice observations from that, and I used put that into a Jupyter Lab notebook. I created some lecture material for my DSP class from that, and then I was also able to hand that data off to my wife and Christine Zagziski and Majid, who were able to put it into the lab simulator that they have running at the university now. So it's been quite good. Hopefully, during the open session, I can show some of that. Back to net.
Okay, very good. Next on the list is Dave, KD0EAG. Go ahead, Dave. Did he freeze? Oh, there he is. You're muted.
Um, can anyone hear me?
Yes.
Okay. Well, as usual, things are not working as planned here. So I had to do a last minute switch to this laptop, which I used last week, but did not fail to plug back in to charge up. So, uh, um, and it of course doesn't work with the earbuds, on and on and on. Anyhow, I've been busy, but I don't know how much I've accomplished today. It's been very frustrating all because of bad USB sticks, I think. They seem to go bad. And but otherwise, I really don't have a lot to report. So um, I I I would note that there's some talk that the reason they grounded all the A20s, Airbus A20s over the weekend and redid a lot of their software seems to have been due to the magnetic storm last week. At least it's rumored to have been a consequence of that magnetic storm, solar weather problems last week. That's so at least what we're doing addresses some things that are of interest to people. Anyway, that's it for me. Take care.
Okay. Next on the list is Dave H, W6OQ. Go ahead.
Good evening, everyone. Let's see, not enough radio stuff this week, like none at all. But here I am, ready to learn what I can learn tonight. Thanks.
Very good. Uh, Next on the list is Dave Julian, WB9YIG. Go ahead.
Good evening, folks. Busy week frying turkeys and got a WinLink station set up, converted it over from packet to Vera, playing with some micro or nano VNAs, and even starting to work on some of David McGaw's stuff for his satellite. But other than that, that's about it.
Okay. Next on the list is David McGaw. Go ahead, David.
Good evening, everyone. Um, Not too much to report, just pulled in from our Revels rehearsal. And our CubeSat continues to orbit, occasionally resets itself for no known cause, um, but doesn't seem to be related to solar activity. It seems to be our program activity. Um, I guess that's about it from here. Expecting what is it, 4 to 8 inches of snow. It's our first big snowstorm, but hoping for powder so it doesn't all freeze up on us. Back to net.
Very good. Uh, Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. Um, over the break, I was working on. I actually finished the VLF interface board. Finished the design in KiCad. I'm actually quite happy with it. It came out pretty good. Now I'm just going to double and triple check everything to make sure it's as it should be. And then I could finally send it to Osage Park to get it built up. I picked a enclosure for it, a Hammond enclosure that's small and thin, and what I'm doing now is I'm working on the end plates. I was asking in the KiCad IRC channel what people did when they made end plates, and they made their own project. That's kind of what they did. So I'm working on the end plates, and as long as I have the measurements right, then those end plates will work out and look really nice. During the open session, I would like to just take a couple minutes to show the renderings of the board. That's all I have. Back to the net.
Okay. Next on the list is uh, Christina is next on the list if she's ready.
Oh, I can be ready. Let's see. Recent activities. Right now, Morris Uzis and I are scrambling to finish our revisions on our Eclipse paper. Nathaniel, I'll probably want to do a breakout room with you if we can, just to go over a paragraph and see if it looks all right. And I got a website going for the MacGyver sessions, which are upcoming at AGU. So I will drop that in the chat for those who might find it to be of interest. There's a number of HamSCI things that have been reported on it in those in the past, and there will be more this year. And that's the main stuff that I'm up to this week. Back to net.
Very
And
good.
I should make a quick announcement about that too, because many of the HamSCI MacGyver presenters are on the call tonight. So I know that Paul Elliott is here and Rob Robinette. If you want to send me copies of your slides ahead of time for me to look at, I'm starting to be at the point of the semester where I can reasonably look at them and comment. And so this is a very busy week for me, but yeah, feel free to send them along and I can email back with comments so we can get that going.
Also, I'll note for those who are doing MacGyver things, we now have a MacGyver logo. So I will drop a line. I'll drop a link to the logo repository in for those who would be interested in incorporating that into their poster or presentation.
And I know that a number of us are meeting for dinner on Sunday night in New Orleans. I'll be sending an email out about that. We're looking for suggestions on where to get dinner in New Orleans on Sunday night. So if anyone has any good suggestions, let us know too.
Okay. Next on the list is Michael Howen. Go ahead, Michael. So you've been a busy person this week.
Yeah, I don't know how it happened. It comes in fits and spurts, but I've made some progress on a couple of fronts, excising the grape part that's currently under the aegis of Whisper Demon, so it stands alone. One of the mechanisms that enables that is a independent library that I've prepared that I'm calling KA9Q Python. And then it interacts with client apps like a Grape Recorder app or a Whisper Recorder app or a Super Darn Recorder app, a Kodar Reporter app or what a recorder app or whatever. Also discovered some interesting things about the timing possibilities of our little kit. I'll share them with you a little later because I would like to demonstrate the applications and the website that displays. So
Yeah.
It's I've also, I should say that also wrapped up in that I've been bothering people about this for a couple of years, figuring out a way to discriminate WWV and WWVH, and I think I've made some progress in that regard too. So I'll share a little bit of that also.
Okay, very
And
good.
that's great. And that's something, Christina, I really want you to see both of those things that Michael has because they're both very applicable to what we're doing.
Okay, next on the list is Paul Elliott, WB6 CXC. Go ahead, Paul.
Yeah, hi. Evening, everyone. Yeah, not a lot, mostly working on Thanksgiving, and since I'm the designated turkey cooker and stuffing chef, so that anyway, and had the family, most of the family at our place in California, so that was really nice. Been working on this RX-88 uh, zombie or hybrid or whatever. A few pieces at a time. I've got all the traces between the FX chip and the ADC, and wow. So anyway, but making slow progress. Also, I was talking with George, or I think we were discussing in one of our meetings about using. I think he's using Cat 7 cable. We're talking about longer cable runs for the, balanced, Glenn's antenna thing. And so I ended up getting some Cat 8 cable, 100 feet of that, and was able to compare it with 100 feet of Cat 5e, Cat 6, and Cat 8, using that little balance thing that I designed. And surprising, and maybe not in a good way, I have not tested Cat 7 cable. If it's a whole lot better than Cat 8, as far as attenuation goes, it might be worthwhile. But anyway, I think there may be work to be done on specifying cables for long runs for the balanced antenna projects. We'll see. I'd be happy to share what I got and look forward to any comments. For Ethernet, attenuation isn't the only issue. You got group delay and all that are factors. But for the RF balanced work that we're doing, attenuation's probably, other than shielding and crosstalk and all that, are the only measurable parameters that, the ones that really matter. Anyway, so that's what I've been doing, and back to Net.
Very good. Next on the list, let's go to Scott N5 TNL.
Hey guys, nothing to report this week. Sorry.
Okay, well, um, next on the list is Tom N5EG.
Oh, good evening, Dave, and everyone in the description. Was just bringing up the TIA-42 spec, which is the cat cabling. So it's all defined in TIA-42. This week, still working on the quad receiver. I've had a bunch of emails with Naveed on a couple of the questions I've asked him, and got a document started, so he's working on that. Found and did the initial build of software for the LVDS application, which is no code. That was all generated from the templates that are provided by Infineon. It claims that it'll handle most LVDS apps, but there's normally there's always a large caveat. All LVDS apps except the one that you're trying to accomplish. So other than that, been a busy week and back to the group.
Okay. Well, we had Clint just pop in, but he's on the telephone, so I'm gonna let him wait for a while. And next on the list is Rob Robinette. Go ahead, Rob.
Better turn on my mic. Uh, well, I've been doing a lot of work, but most of it is not particularly relevant to this. I've been working on the Whisper Daemon server uh, software. The hardware is in place now. We've actually added a third server at Michael's, which is, I think, fully operational. So we've got three fully operational servers that are recording the expended spot data. And the most relevant aspect of it, Whisper Daemon's extended spot, is that the frequency resolution is 1/10 of a hertz instead of the 1 hertz resolution that you get from WhisperNet spot reporting. So our Gwen's and others' analysis work benefits from that additional, order of magnitude more frequency resolution, and allows you to see Doppler shift on whisper signals when you would otherwise not see them, rarely see them. So that is largely done, and I hope to turn my attention to back to the client and work with Michael has uncovered. I think he'll discuss later a number of really exciting opportunities for us to improve the temporal resolution of our recordings. And tomorrow, I hope that Dave Schwartz will get out to. He is scheduled to go out to the WWA 0 receive site and install the system that has the time sync injector hardware. So we have two paths, I think, to improve temporal resolution. The inject a signal ahead of the A-to-D, and the work that Michael, I think, will describe later in this session. So I think that's very, very valuable. A new capability of the system that I couldn't have envisioned possible that it was possible a year ago. So anyway, I'll send it back to the net, and I'll be
Okay.
lurking here while I'm doing other things.
I also noticed I didn't call on Phil. K9Q. Go ahead, Phil.
Hey guys, yeah, I'm here. Let's see. Big thing lately is I've completely revamped the spectral analysis code in KNIQ radio that is used in by KNIQ Web, among other things. The main thing has changed is the wideband mode. Not only is it a lot cleaner in terms of side lobes and responses, it's also a lot lower in CPU. The peak load in spectral analysis mode is now about 2 or 3% of the CPU, which is way down from what it used to be. So it should has no special problems now in running a lot of these sessions. Anyway, that's it. Back to you guys.
Very good. And I think I've called on everybody. Anybody that I miss that I should? I think,
Clint, if we passed by him.
yeah, Clint seems to be on the telephone, so I'm gonna
Okay.
let him finish his phone call before. I'm sure he'll speak up when he has an opportunity. So I guess now we're open for general discussion. And I don't know, Michael, do you want to talk about your stuff or?
Sure. Let me just say I'm going to share something first. There's,
Oh, wow.
it's amazing what a little AI can do, right? Which one are you seeing here? There's Phil,
Phil.
rock star wrapped in Python. So that's the theme for what I've
Oh
prepared
God.
here.
Oh God.
What do you think, Phil?
AI
And then
is going to be the death of us all.
this is what I feel like here. This, you see this elephant?
I got to show
Yeah,
this to my wife. He's going to love this.
So, Mike, when are
riding
you going
on.
to start showing us the AI images?
Well, this is an AI image.
I know, I'm kidding.
So anyway, let me switch to something else. What other? Can you see this?
We're just seeing Phil.
Phil.
Still Phil. Okay.
What else do we need to see, though?
Yeah, well,
Yeah,
true.
really.
Let me
Jesus.
stand by a second. Let me get the other thing I wanted to show you then. Where is it? Single 10. Here it is. Okay. So let me start at the beginning here. Summary. This is a grape signal recorder. It's got my station information, timing status. I'm listening to Radio D via my what I've written as an intermediate called KA9Q Python. And I have a core recorder function in that, and then analytics that are for grape specific stuff. What this shows down here are the 9 channels, whether the RTP stream is actually live and green, what its current SNR is, what the time sync basis is, which is tone. So in that case, it's synced with the tone from the time signal station. And I can click on one of these things and listen to it if I want. Well, you probably can't hear that anyway. The second, this stupid thing is in the way. Can I get that to get out of my way? Well, I'll have to do this. There we
The
go.
UI on this looks so clean.
Yes.
This is a carrier analysis. So if I go to a better day like this, I can look at 10 megahertz. And I've got, I'm sorry, I have to figure out why all these vertical lines are in here. But what you're seeing is obviously a spectrogram. It's the regular 5 hertz spectrogram. This is a power graph. And you also see the solar zenith. One of them is the solar zenith between my location and Kauai, and the other one is between my location and Fort Collins.
Oh, that's amazing.
So you can kind of match this up with what's happening on here's where the dawn is. It's crossing the
Wow.
0 line. And then you can see what the power is doing as it kind of goes up during the day, along with the regular spectrogram stuff that you're used to seeing over on PSWS. If I go so I can look at that on any day that I've been gathering data and on any of the 9 frequencies. This is driving me crazy. If I go up to the top of the screen, this stupid thing pops up for sharing. I can't get to it. Let's go to this. Well, I don't want to go to that just yet. That's the good stuff. Shit. How do I make that stupid bar go away on the top?
I think you can drag it to the bottom.
Oh, thank you.
That's usually what I do.
All right, this is discrimination analysis. And so, as you know, and I learned a lot from Bill about this regarding the transmitter characteristics. There's trouble when it comes to trying to figure out what's going on 2.5, 5, 10, and 15. And so what I've tried to do is come up with as many different discriminators as I could and put them together into a kind of metric. So I'm using the test. Christina asked for her signal, so she kindly sent it to me, and I've put in a means of looking at that. I'm looking at the 440 hertz tone, which is broadcast in minute 1 by WWVH and minute 2 by WWV. I'm doing a BCD amplitude sliding cross correlation, looking for both WWV and WWVH and showing those things. I'm doing the timing tones over the 1 minute timing tones. So that would be the 800 millisecond tone at the beginning of every minute on 1,000 hertz for WWV and 1,200 hertz for WWVH. You can block out one and superimpose or block out the other. I'm doing a sliding window of second ticks as well. I can't make it too long, as Phil pointed out last week, because the longer you make the window, the more phase trouble you get into. So I'm trying to keep it kind of short. But you can see some of the characteristics of the ticks. They're actually good. And then there are a few minutes in an hour when WWV only broadcasts, minute 1, 16, 17, and 19, and WWVH as well. And so you can pick those. I can get rid of the ones where this is only WWV and this is only WWVH. And this is some differential Doppler analysis. This is some coherence. Phil again mentioned how important coherence time could be for discussing, considering what the capacity of your channel is. So I've tried to measure some of that. This is a harmonic ratio. When WWV or WWVH broadcasts on 500 or on 600, there's a second degree harmonic that will distort what's happening on 1,000 or on 1,200. So I'm measuring the difference in the volume of the 1,000 and the 1,200 based on whether 500 or 600 are broadcasting in that minute. And I'm getting some good discriminatory data as a result of that, which is kind of cool. And this is a weighted voting. On this particular frequency, on this particular day, I've heard WWVH 46% of the time that it was dominant, and 53% of the time WWV was dominant. You can kind of peel in and look at this in more detail and see that there's moments, most of the time WWV is dominant. So I'm starting with the limited, with a single antenna. There's not a heck of a lot you can do, but I'm figuring I'm getting about close to maxing out what you can get out of it to help discriminate what's going on.
But the thing is, I think the more we can get out of a single antenna, the better, because that's what the majority of people are going to be having.
Sure. Well, no, without question. That's why I wanted to keep going on this. And then this is the fun part that I was just getting into this afternoon. I finally realized, got through my thick head, that the RTP stamps could be put to really good use. They're based on the ADC sample rate. They're constant. They're shared across all of the samples that are coming across the RTP streams. And so what that means is I can do these timing cross correlations between channels and use the toning sync that I can get out of, these are time standard stations, of course. So if I sync up with them properly and determine, especially on strong stations, what the sample is, where the upslope on that 800 millisecond per minute tone is, or 500 milliseconds in the case of CHU, I can use that to really narrow down what I'm looking at on the weaker stations and pick out what's happening, the signal out of the noise, much more than if I was looking at one of those stations by themselves. And you can start to break out based on the what you know about the geography of where my station is, as 1,120 miles from WWV, 6,600 miles from WWVH, and 1,520 kilometers from, not miles, kilometers from Toronto. I can get these predictive delays, and then I can measure the variations from the delays, and I can get just a ton of good quality information. You can see the delays are short for WWV. They're a little bit longer for CHU. They're longer yet for WWVH. and it's even possible to break out a differential delay based on what you expect the STIP is going to be on the different layers. This is telling you what the average SNR is, I guess. And so what I'm seeing here are some really kind of low, well, this can't be right. But this is sort of my drift analysis kind of going across, summing up all the things. And it's nice and low. The more data I gather with respect to this stuff, if I integrate, because I can sum these all up, I can sum up the magnitudes of the signal, and I can eliminate the square root of the noise, and I can start to actually zero in on a really, really accurate timing, which then I can even back calculate to what the time must have been at the transmit station because of the geography, and get something close to, the NIST time actually. So I just was doing some of this stuff today, so I'm kind of eager. I mean, one of the motivations was something Rob had said about how he wanted the Whisper to be synced, but Whisper doesn't have its own inherent time signal. But if you're measuring WWV on the same machine and you're sharing the RTP timestamps, and you can sync them to UTC time with a good strong, not just a single WWV or CHU signal, but the integrated sum of all of them, suddenly you've got a fabulous time source that is, a tiny expense compared to what they build in Fort Collins, and that we can use for a whole bunch. It's interferometry. It's the same sort of stuff that's used in astronomy, and the astronomy is also kind of a motivating thing for me too. I mean, I've done photo stacking, with shorter exposures, and then stack them together with some dark field interleaved to improve the contrast, to get higher quality astronomical photographs. Well, this is the same kind of signal processing that this is possible with. So also gap analysis is another feature that I wanted to analyze, because right now, for instance, the DRF, the digital RF that we upload to Personal Space Weather Station really just has the spectrogram information in it only. It doesn't have any significant metadata about timing or gaps. And so I was interested in what you all thought would be a useful set of metadata to add to the digital RF that would, enhance the overall description of what the data was, where there was gaps. I can even quantify why there was a gap. Well, there was a network outage and the RTP stream was gone. The RTP stream was there, but the payload is corrupted. The RTP stream and the payload look fine, but my monitoring program on the machine was down. That sort of thing. But I would think, I mean, I'm not a scientist, but I would think that having a better handle on where your data was confidently good and where it was sketchy and where there were gaps would be helpful.
Yeah.
And so that is it.
This is amazing.
Any question? But I think I mentioned whether you saw the other photograph that I wanted to share, because that's the really important one. It's this one, because this is what I feel like. I mean, I'm riding on top of Phil Karn's work. I'm making liberal use of AI, and getting advice from everybody, and so there's really heavy lifting going on, but it's not me. I'm having a lot of fun just riding the elephant. So that's more. I don't know, that was AI too, I suppose.
Hmm.
Anyway, there's some practical things, to decide, like the metadata,
Mm-hmm.
whether you want to add any of that metadata. Uh, I noticed that Christina's time test signal, the recommendation was a 20 kilosample per second bandwidth, and right now there's only 16 kilohertz being stored but that's an easy enough thing to change. I can just change the bandwidth to 20. For the local storage, you'd still decimate down to 10 or whatever it is you want to get the narrow carrier information, but that would give me better quality um, of usage. I mean, 16 still catches most of the time, I mean, of the test signal, but the recommendation was to go up to 20 to make sure you weren't cutting off the 5 kilohertz tone. So um, anyway, that's what I've been working on. The nice thing about the Python that I've written is I can have it on different machines, which is kind of nice. I don't have to try to compile control on another machine, or monitor the things that are. I've never figured out how to compile them on my MacBook. I know Phil runs them on his MacBook, but the this way I can run it. What I haven't figured out yet is the burrowing. I mean, managing the multicast through an IGMP switch. I tried it on a couple machines outside the switch, and it was choppy and not really usable, at least on audio. I can run it on any machine that's on the same side of the switch as the machine running K9Q, and it's like it's running on the same machine. So at least that part works. Still have to crack the IGMP nut. Okay, I got nothing else.
Christina, what do you think?
Just that.
Is that on?
Well, I think you've knocked my socks off for one thing. That's fantastic. I can't wait to start playing with this.
So
this is fantastic.
Yeah, Michael is really, really impressive. I mean, I am impressed. Question for you though. I might have missed it, but what is the method, I mean, that you can work back towards actual time of arrival? I mean, you've got the distance and you've got the differences between different, distances between your receive site and the multiple transmit sources, and you've got deltas between them. And it seems like there ought to be some way um, you can arrive at your actual um, time of arrival based on that, but I think it's eluding me. Or is that not? Um,
Well,
are you able to get actual time of arrival out of this?
Yes. Well, let me make sure I'm describing it correctly. The idea is you've got the upside of these permanent tones that is giving that you're matching exactly with the sample of your RTP stream, and then you can sync the RTP stream to that. So you've got that. So you have a kind of relative time of arrival, and you've got what is nominally UTC time coming out of the time station. Now you also know your geographical position. You probably can guess some variance regarding ionospheric delay and the mode of transport. That's all the propagation. So you just work the equation backwards to get the time of emitting. You take the time of arrival and you subtract the time factors associated. Yeah, associated
The propagation
with
delay, but that's something that you don't have. I mean, you have an estimate, an educated guess or an estimate. But if you had, let's say you had only one time standard station you were using,
that'd be a lot less accurate, right? It's going to be but when you're calculating, what you're doing here is actually using 4 WWVH stations, 6 WWV stations, and 3 CHU stations. And that is
And
what starts to get you able to narrow down. And when you know the geography and when you can make some assumptions about the propagation, then
it's the assumptions about the propagation delay, I guess. So just being able to put a number on that, a
Would it,
bracket around that.
now, if you had timestamps from a local pulse per second, GPSDO pulse per second, you could do better, right?
Now, that's kind of what I'm working toward,
Right.
trying to figure out. I mean, Michael, have you obsoleted our local, PPS local source here? I'm
I
just
don't
wondering.
know. It's worth
That would
testing.
be
I'm really
pretty
just sort
cool.
of
I
getting
mean,
into this for the first time, and so there's a lot of people. Rob pointed this out. There's going to be people who are going to get a Daisy kit, which is going to include a PPS injector. But there's a lot of people out there already who are running an RX 888 and a B-Link with
don't
GPSDO. They may
no,
be able to get in the
don't get
ballpark.
me wrong. If you've solved this, or at least within some known, degree of accuracy that's, useful, and I believe you have, at least the useful part, um, then that's wonderful. I mean, if it's a software solution, I'm all for that.
Yeah.
I've
But
got I don't need to make hardware.
Well,
Um,
I still think we should, at least I need to understand this a little bit better. And then even if we do understand it, I think we should still have a system where we can inject a local known GPSDO pulse per second. And if it does in fact work, you should be able to do the calculations independently using the GPSDO, and then you should also be able to do the calculations independently using this other method, and then you should be able to demonstrate how well they match.
that would be a very, very enlightening test.
And I think all of these things, like, yeah, so I mean, I think that's something I would root for.
That's what we'll be doing at WWV. I mean, Dave Schwartz says he's going to take out the equipment tomorrow. So
And
we'll finally have the time signal injector out at WWV. So we'll be able to then add a Michael's code to that machine, and we'll have a machine that's sitting next to the WWV where we can compare the results from his with the results that we get from Paul's and Scott's.
The other thing I'd really like to see. Go ahead.
I'm really looking forward to the WWV0 installation, but I will say that the variation in propagation delay due to other due to guesswork factors, really isn't there with the local WWV receiver. So in a way, that's kind of cheating, although it'd still be a good test.
I think yeah, I would definitely vote to see the hardware GPSDO PPS device, fully realized and installed and running, and then do a real comparison. How does that match up with this technique? And the other thing, I'd like to see some of these like developed into actual like peer-reviewed papers, because I think that's really going to be where it gets documented and vetted properly. And I think that's true for this timing technique, and it sounds very novel and useful, but I think going through that exercise of writing the paper and getting it through peer review will really be enlightening. And then same thing with the WWV WWVH discrimination. I'm really curious. Like, I really wish I had more time, but maybe I think maybe we can just find the right people to write this. I would love to see a paper that takes your WWV discrimination algorithm and then does a careful study of that and compares it with outputs from the propagation model, and also from Farlap ray tracing, see how well they match up. And I'd like to have that done not just at your station, but I'd like to see that same sort of thing done at multiple stations. And I'd like to see, I'm kind of envisioning these maps or some way of looking at making these WWV versus WWVH measurements and well, essentially climatologies across the entire network. And like I would think that you would, most of so my hypothesis right now is that most of the PSWS stations on the eastern seaboard of the United States are hearing WWV most of the time. But is that really true? And, if we did a real statistical study on the whole network, we should be able to see patterns, and this pattern should be coherent and explainable. And if the patterns do emerge and are coherent and explainable, it should give additional evidence that your discrimination method is working.
Yep.
And I think maybe one question I have is, once we get this all implemented, who is the person that actually goes and does that study and writes that paper? And, maybe we ask for volunteers, or maybe Christina and we have a talk about it. Or I was thinking, there's Sarah Over, who's from Virginia Tech. She's kind of been looking for a project that she could, I think, take some ownership of. And she has a PhD in space physics and like data science. And this might, and she's already working on a team supporting some of my undergrads, working on the Gannon storm with the personal space weather station data. She might be just the right person to, take your methodology and actually apply it to the whole network and try and write it up into a paper. So I don't really know who the person is for that, but those are I think this is all really promising. I think it's really exciting. I think, figuring out how to continue to develop that. And the other thing, Christina, I think what we should do is I think we really should make sure Bill Engelke is aware of this.
Yeah.
And I think we really want to, as we're doing this charrette, I think we should talk about how this information gets put into the main, database website. And even, I think I've put some, we have some items in the charrette about, coming up with a way of scheduling recording times on the server side and pushing those scheduling requests out to the receivers. And it seems like, Michael has such a nice UI here and like dashboard. It seems like building onto that and figuring out how to integrate his recording dashboard system into that part of the project really seems like a compelling thing to do.
Absolutely. And the other thing I'd really like to figure out how to connect up if we can is GNU Radio. If we can get all those things talking to each other, that'll open up a lot of possibilities as well.
Yeah.
But this looks amazing. I can't wait to start playing with it.
This is nice.
Yeah.
I mean, I brought it up in just a couple minutes and I don't like usually installing Python packages.
But it actually worked, huh?
Well, yeah, I had to install 3 or 4 packages. I see one minor glitch when I do the pull down menu to select a radio DOE instance. He's not de-escaping the character strings for the instances. Other than that, hey.
What framework are you using for your UI and everything, Michael?
It's all Node.js.
Okay.
Yeah. Although there's, I think I built a little UI that actually mimics a little bit of what Phil's control and curses display does, using a different one.
What can I do with it? Okay, I select an instance and it lists all the channels on that instance and what their status is. Can I do anything else with it right now?
No, it's not interactive in that way. It's just sort of just passive display. You're looking at the UI on the K9Q Python package, right?
That's right. That's right.
I want to switch over to Jonathan in a minute because I know he wanted to show some things. But um, before we do that, I also wanted to say um, I am, there's a couple of other dashboard projects going on. So now Michael Howen has a dashboard project. Um, I have a student, Jackson, who's working with Dave Witten on a dashboard project for the magnetometer. And then I have another dashboard project that we've got going with the Frankfurt Radio Club that's making a dashboard to do visualizations of the Whisper Demon spots specifically for contesters. And then with that project, I'm now starting that UI. I think it leaves a lot, it's kind of showing what we need it to show, or it's starting to, but it leaves a lot to be desired in comparison with the things I've seen from you, Michael, and from Dave Witten with either Dino or this Node.js stuff. So I'm starting to talk to my computer science department. I'm trying to see if we can enlist some senior undergrads who have to do capstone projects or a web design course that have to do projects, and seeing if they can participate in our dashboard project as well. And I think maybe this is starting to come back to a project management question. Now that we have all these dashboards running around, should I be thinking about how to integrate them? Like pick one framework and we all work with that, or is it better to kind of let them all develop organically for now and develop a little bit further, and then try to create something unified after we have a number of different kind of little dashboard fiefdoms? I don't know. What do you?
Well, my own feeling about the dashboards was, go ahead. Go ahead, Dave.
I'm sorry. I just want to point out that Dino and Node.js are very, very closely related. Dino's a little more secure by most accounts. There's also one called Bun. They're all in the same family. But I also show you, I think I sent you, I had something tell me what it would take to, how much work, and whether I could translate these, say, to Python. And I kind of sent you its response to that, which was, sure, I can do that. Just tell me when. And so
I've been playing with
great.
some of these AI stuff over Thanksgiving and having it write code for me too, and some of it sounds really good until you actually look at the final output. So you have to be careful with what it you have to be a little careful with what it promises.
Yeah, well, you got to know what to ask for.
Yeah.
But it's like the thing about the genie in the bottle and the three wishes, Um, uh, so often, if you're not very careful what you wish for, you get it. And but all in all, it's that that would be a good discussion to have, because there's so many ways to go. There's only about 50 other choices that we aren't even thinking about. These are just what I've been doing is my own personal
I'm going to be meeting with the CS professor for the web design course next Monday, and I for the DX dashboard contesting dashboard project. And I think what I might come out of this is trying to write up a document that at least from the DX dashboard side of things, kind of spells out how we'd structure the project in terms of classes and stuff. And I think in terms of how we'd split it up into student projects and how we would do that. And maybe what I'll do is I'll bring that document when I have a draft of it over to here and get people's feedback on it. And maybe we can see if there's, common threads that might tie these different dashboards together. Because I think it would make sense to have like a single, kind of UI that you go to where, okay, you're running the RX 888, you have a UI that does the Michael Howens recording and controls the RX 888, there's a similar, basically the same UI for the magnetometer. I think ultimately that's what we would like. But I do also know that, yeah.
I was going to say that what will make it a lot easier for us to decide is if we really keep all the application logic out of the UI.
Yeah.
Because then you can
Yes.
flip back and forth to different things, and you can spin up a UI really in a matter of minutes.
Yeah.
If the data is all sitting there separately and you've got a well thought out API for how to interact with it, where to find the data, and that kind of thing.
I think you're absolutely correct.
The other thing is that sorry, go ahead.
Well, I was only going to say that having a spec for anybody who's working on one of these projects is to include in there an emphasis on making sure all the data generated and the analytics and stuff are separated from the UI.
Agreed. I was going to say having multiple dashboards. I mean, I think we all have the instinct to be like, one dashboard to rule them all makes the most sense. But on the other hand, like you operate with multiple dashboards all the time.
Yeah.
You pull up your RBN on one side and your, WhisperNet on the other, and it's totally fine. You can just put them next to each other or embed them in one page, or if it depends on if they're being interactive and how it won't be as robust.
And that might be the answer. I just want to make sure we're having this discussion sooner rather than later.
About containerizing some of this too, because certainly anything that might come off of academic servers, and also situations, well, also if you go talking to the CS people, they're going to be, petrified by some of the possible UI tools that they're probably not real familiar with. In the real world, there's a lot of reason to stick to to standardize parts of this anyway. So I'm in agreement with everybody on that.
And maybe Jackson, maybe Jackson might be able to help give his perspective too, since he's in the. Well, I'm trying. So I'm thinking of it in terms of how am I going to split this up for students in the computer science program too. So that's what I'm saying. Maybe I'd bring Jackson because he actually is a computer science student and understands how the computer science students think. Anyway, I think we should continue this discussion later. If Jonathan's still there, I'd like to give him a minute or two to show what he's done, because I think it's Jonathan. Are you there?
Yes.
Great.
Yeah, I could just run through these pictures quick. So this is a rendering of the single channel VLF interface board that I was working on. So what this does, what the purpose of this is that this interfaces the VLF active antenna, the preamp specifically. You could see this green terminal connector here. That connects to the feed line. We have some gas discharge arresters, bleeder resistors. This here, this is the DC to DC converter. Some decoupling caps. This is the isolated, or the audio isolation transformer. So it picks off the signal and it supplies power. Both are isolated. And this blank space here, if you have a particularly long feed line run and you need 48 volts instead of the 30 that would come from this DC to DC converter, you would simply install the 6-watt DC to DC converter instead of this 3-watt. You obviously would not put them in at the same time. The VLF signal that is taken off of the from a phone jack into the sound card. There's a LED, power LED to indicate power, and a power jack. And Paul, thanks for that idea with the P-channel MOSFET as the ideal diode. So I have that in here for polarity polarity protection. But anyway, yeah, this is and if you notice here, there's this text. This is just some added text. This is the part number for the case that it's going into. So I did the dimensions and everything of the board based on this Hammond enclosure. It's only like $20, and it's a really nice enclosure. So it'll complete the system rather nicely. Here's another view of it, and this is the bottom view. One thing that I wanted to mention is that there are two ground planes, and those ground planes are on the isolated side. So that's the side after the isolation, which is in between the DC to DC converter, the audio isolation transformer, and the feed line, which is basically like the loop side. So this is all isolated from this portion here, which is the portion connected to the outside world. So I tried to I'm curious to see how this would work. I think it would work quite well. And I modeled this off of what Paul Nicholson already did with his Raspberry Pi system that is used in the Indian Lightning Detection Network. So he had what he called the back-end processor, which contained the Raspberry Pi and the GPS and the power supply, and basically this circuit right here is what was on his board. So I wanted to preserve that because it worked well. It worked well on my prototype system. So what's next is I'm going to verify mechanical fitment in the enclosure, and then work on the end panels and make sure that they work out too. And I'll use OSH Park to avoid the import fees with JLC to keep the price down. That's all I have for that. One last quick thing that I wanted to mention. Nathaniel, you mentioned that the GPS timing method that you guys use is novel. The method that's used with the VLF system, and also using VLF-RX tools with what do you call it? RTL SDR in the VHF bands for meteor scatter. That's also novel as well. And I have mentioned that method before, but he obviously uses, he turns on and off just a carrier, where you guys use a, was it a BPSK modulated signal instead of just a keyed on-off carrier by the pulse per second. So that was also novel, and I only wanted to mention it because I wanted to give Paul the credit, because Paul definitely came up with that with his with what he did.
We were talking
That's
about
all
it.
I have on this. Back to
That,
the net.
and when we say Paul, I think we're talking about the VLF
All
Paul, right? Not me.
correct.
Okay, just checking.
Correct. Yes. Paul Nicholson. Yep. Yep.
That's great, Jonathan.
So I see that Phil had a question in the comments. Phil, did you ever get that answer?
Oh, I was just commenting on Michael's really cool Python package here. That it only took me a few minutes to bring this up. I do see a couple minor glitches, but I messaged him about them directly.
Okay.
Hey,
Also, I need a
quick-
copy of that picture for my wife. She doesn't realize how awesome I am.
No, they never do. They never do.
I wanted to show something really quickly too. What I've been working on over Thanksgiving break. So let's see. So what I did, let's show this. I've been looking. Do you see my web browser here
There.
with GitHub? So I've been looking at magnetometer data from the magnetometer in my backyard, and I looked at it during the geomagnetic storm that happened in May of 2024. And so here you can see all three components over here, and you can see that there were really some very strong disturbances. I've removed the background mean of this, and you can see the excursions, reach between like plus 800 nanoteslas, and it goes down to like minus 1500 nanoteslas. So some really big excursions. If I just pull out the two horizontal components and take the magnitude, or what I think are the two horizontal components, I get something that looks like this. So this is like the beginning of the storm, and then here's the recovery phase. And this hasn't been carefully analyzed yet, but you can definitely see there's definitely something going on in my magnetometer. Now, I did a couple of things with this data. One thing I did was I wanted to have a demonstration of how to do filtering in Jupyter Labs for my digital signal processing class. And I wanted to specifically show off something called PC5 waves. So if you PC5 waves are waves that you'd expect in the ground magnetometer data that have frequencies between 2 and 7 millihertz. So that's periods of 2.5 to 10 minutes. And these are often associated with field line resonances of the magnetic field lines. And you might see them during geomagnetic storms and other times that you get excitations in the magnetic field lines. So I wanted to be able to take that data and I wanted to be able to filter it for those particular frequencies. These are very low frequencies, and it's a very narrow band, just going from 2 to 7 millihertz. So using the built-in Butterworth filters for Python, when I first was doing this, I was using the standard like BA form of the filters that Python has, which just gives you the transfer function in this form. But I found that was extremely unstable, especially for these low frequencies. So I found that if you use the second order sections approach, which is where it takes this transfer function and breaks it up into a cascade of filters that are just second order transfer functions, then it's much more stable. So I created a Python notebook that demonstrates all of this. So here's the original data. Here I'm using the SciPy tools to create the Butterworth bandpass filter using the standard form. And then here's the pole zero plot, and you've got lots of poles outside the unit circle. And here's the frequency response. It's extremely unstable and just not usable. And if you use the other method with the same parameters, so we have like a 100 dB attenuation, now all the poles are inside the unit circle. We have a very nice flat response to the Butterworth filter. You see the phase response here, but I apply the filter forwards and backwards, so it ends up being a zero phase filter. And then here's the final result. And so the blue line is the unfiltered data, and the orange line is the PC5 band filtered data. And you can see nice PC5 band oscillations here and here during this storm.
Why not just use an FIR filter?
That's a possibility too.
They're always they're always stable.
So that might be a better way to do it. I know that. So the reason is because I started down this particular path, and this is the solution I came up with, and it seemed to work. But yeah, I think maybe for next year's class, I might also demonstrate doing it with an FIR filter.
Was there any decimation in this?
I don't. No, I don't think I did any decimation. I kept it at a 1 minute cadence. I did resample the data just to make sure it was at an even 1 minute cadence.
Nathaniel.
Yeah. The other thing I wanted to show was that I then also gave this this data to my wife and Christine Zixuski and Majid, and they were able to put it into a function generator. So they took that same waveform, they stuck it into a why don't do that? There you go. Into a arbitrary waveform function generator, which is then connected to, you can also see the output of that on this oscilloscope. And then I guess it's not showing on this screen, but then it's sent out to Helmholtz coils that go around a magnetometer in the lab. So we're trying to demonstrate that you can just reproduce the same waveform in the lab. So they have that going now too.
Cool.
So that's what I wanted to show.
That looks really good. Hey, I got to run, but before I go, Michael, let me just give you a hand here, applause, because again, I think that is really impressive what you've done there, and beautifully presented too. So thank you. Look forward to seeing more of all this stuff out in the real world, and see. I'm just gung ho on time of arrival, time of flight, and all that stuff. I think time is our next dimension here, and that's always been my favorite dimension.
Me
So
too.
anyway, good night, guys.
Good night.
Good night. Thank you.
Nathaniel, can I borrow you in a breakout room for a minute?
Yes. I'll
Awesome.
stop the recording. Thank you, everybody.